Jean-Pierre, please
Hello,
go ahead.
everybody. Hi, Kiran.
Yeah, please go ahead. Yeah, you go ahead. Yeah.
Hello, everybody. I am Jean-Pierre Bien-Aimé, here acting as Senior Advisor International Relations for TSDSI. I'm very glad to, after the welcoming of Bindu, to open this session on rural 5G for remote and rural areas. Just a reminder of what happened in the last months. As it was said in the nice film presenting TSDSI, TSDSI RIT was accepted as an independent standard, mainly for 5G remote, at the ITUR meetings this year, and confirmed at the last October ITUR Work Party 5D meeting. We will have there 3 keynotes, followed by a long panel. At first, for the keynotes, first keynote will be delivered by Professor Kiran Kuchi, Associate Professor IT Hyderabad, who will, let's say, present main highlights of this TSDSI RIT and other features for 10 minutes. Then we will welcome my good colleague, José Marcos Camara, Brito, from Secretary General of 5G Brasil, and also Associate Professor Inatel in Brazil, who will present 5G for remote areas, the missing scenario, and we will see there how Brazil could have some similarities with India and thus involve some further cooperation in this topic. Then we will welcome Federico Boccardi, who is a Principal Technology Advisor at Ofcom, the communications regulator in UK, who will give us his vision on this 5G for remote areas and how what is done in UK and how the future could be managed. So without waiting, I give the floor to Kiran Kuchi for his keynote TSDSI specifications update for IMT 2020.
Thank you, Jean-Pierre. Can you hear me?
Yes.
Okay, thank you. Good to see you. It's been a while. We met sometime 2 years ago in China, I guess. I'll be happy to present on this TSDSI RIT. Let me share the screen. So can you see the screen?
Yes, that's fine.
Okay, I'll go ahead. Thank you. So today, I would like to give an update on the IMT 2020 TSDSI RIT submission to ITU. So I'll begin with a little bit of background. That the short video that you have seen pretty much captures my first slide. It's coincidence. But nevertheless, I'll go over the motivation and the background behind the submission of TSDSI RIT and the salient features of this RIT. I will also briefly go over that. As you can hear and observe, for the last 12 months or so, there has been a lot of emphasis on 5G and IoT in India. There is a significant emphasis on domestic telecom manufacturing placed on this, especially by the government, and many entities are stepping up. Coincidentally, TSDSI has been working towards the same goal for the past 4 or 5 years. that has culminated in the submission of the ITU Working Party submission, that is the RIT. So one of the key reasons and the requirement for this RIT submission is to address the coverage, that is the rural coverage through large cells. And I will talk about in the next couple of minutes the genesis of this so-called LMLC concept, low mobility large cell, which has been introduced at ITU. Before that, just a few numbers on the telecom status, especially rural India. Mobile broadband, as you very well know, has picked up quite prominently in India for the last 2-3 years. One of the most important statistic that you would like to note from this is there is a nearly equal split between the rural and urban voice users. That is about 640 million versus 500 million urban versus rural. That's a fairly staggering statistic on the rural-urban split, which is quite different from some other countries. So for the first time, the number of users using internet seem to have exceeded, according to one statistics, Times of India. And especially in the current scenario, internet access in the rural areas is very, very important. In fact, I have about 100 people working with me presently, and 20 or 30% of them, or even more, are working from villages, and they're operating from the rural areas. So we do need good internet access. One of the key activities in this space is the rollout of fiber on a massive scale by the Indian government. Even the statistic, the numbers are fairly large. 2.5 lakh, that is 250,000 Grama Panchayats, which are basically a group of villages clustered together. These so-called Grama Panchayats are all supposed to have fiber connection, and from the fiber drop, you need to serve several kilometers, so-called last mile. So that is the prime motivation behind the rural coverage with respect to BharatNet rural broadband scenario. So just to give you a graphical illustration of the basic architecture of BharatNet, there is a fiber drop at so-called Grama Panchayat, that is GP, and you have so many villages scattered within the purview of this cell site. So has this been considered, this kind of a structure and scenario, what has been done in rural in the past 20 years, both at 3GPP and ITU, we'll see what has been the case. Before that, what are the requirements on the cell sites? We have taken the statistic. This is the statistic that is given to me by my good friend, Professor Ganti, IIT Madras. The cumulative distribution function of distance from the cell site of all these various Gram Panchayats in India, it turns out that in order to cover 95% of the villages in India, you need a cell radius of 6 kilometers. That is an intersite distance of 10.3 kilometers. This is what we took to ITU, a group of academicians and Indian industry and as well as TSDSI to ITU, and we projected this requirement at ITU during the IMT 2020 requirement phase. So what was the prevailing status at the time? Till IMT 2020, ITU did not have a rural use case that is suited to rural needs of developing countries. It's very surprising, actually. You know, we are talking about 5G, but there was no test case. There was no technology requirement set till that time, until we brought this contribution to ITU. So after a lot of, push and pull, the 10 to 12, we wanted 12 kilometer ISD, the original submission from TSDSI. And finally, an intersite distance of 6 kilometers has been agreed as a mandatory requirement for rural EMBB test case for IMT 2020. Okay. So this is the first time ITU has deliberately introduced such a large cell scenario as a mandatory condition for passing IMT 2020 when the submissions are made for 5G. The TSDSI RIT, which is basically designed to meet this particular test condition along with other requirements of 5G, passed the step 7 of 8, and the final, I think, ratification is more or less a ceremonial process. So we can say that this RIT has passed all the tests. So what is that special about this particular radio interface technology? So what we have done is that we wanted to keep all the good things that 3GPP specifications have offered, but wanted to add a specific enhancement towards meeting the so-called LMLC requirement. So a particular waveform was included in this RIT. It is an uplink waveform, which is central to LMLC coverage expansion. And this particular waveform gives you an additional transmission power advantage, and that leads to 70 to 80% increase in cell range. And this particular operational mode is a form of new modulation, which is called pi/2 BPSK with spectrum shaping, and it can boost the transmission power to at least 26 dBm during the transmission of the signal, and yet the average power is still limited to 23 dBm, which is this limitation to meet the SAR requirements. This is, in a nutshell, one of the key contributions made in this RIT, in addition to other features, which I will not talk about due to paucity of time. So just to summarize quickly, TSDSI has now submitted an IMT 2020 5G RIT, which has been accepted. This is the first time India has in fact contributed at the global standards level with some substantial technological component addition to meet a certain requirement, which is the rural coverage requirement. And this requirement is expected to provide 70 to 80% increase in the cell range. And the target is to have cell sites with an intersite distance of anywhere from 6 to 12 kilometers with 5G deployments, especially operating in 3.5 gigahertz TDD bands, which is supposedly the likely band where 5G is going to be deployed. So that's with that, I will conclude my presentation. I thank everyone.
Thank you, Kiran. Nice presentation, on time, and clear summarizing what is TSDSI RIT, nearly at the end of step 8 with the step 7. I propose that we go with the questions inside the panel, if you agree, in order to master the time. So I would like to welcome now as a keynote speaker our colleague Brito. So José Marcos Brito from 5G Brasil. So Brito, just to mention that I had the opportunity 2 or 3 years ago in our previous relationships and global 5G events to see your advancement in 5G remote and what was your ideas for Brazil, and also international cooperation throughout the 5G range project of the 5G PPP between Brazil and Europe for this missing scenario, as you say, or why not this fourth pillar for the IMT 2020? So please, Brito, I give you the floor for your presentation. 10 minutes, please. Thank you.
Thank you, Jean-Pierre, very much for inviting me. I will try to summarize for you the view of Brazil about the 5G scenario. I will share my screen now. Are you seeing my screen?
Yes, you can put that in. Yes, it's okay. Fine.
Okay. I will summarize the view of Brazil about the 5G for remote areas, the missing scenario. As Jean-Pierre introduced, I am Brito. I'm a full professor and the research director at Inatel and the general secretary of Brazil 5G Brazil project. As you know, 5G was designed considering only 3 scenarios: enhanced mobile broadband, massive machine type communication, and ultra-reliable low latency communication. And the performance requirements of these scenarios are related to peak data rate, about 10 gigabits per second, a user plane latency about 1 millisecond, and the number of connections about 1 million devices per square kilometer. The question is, what is missing in 5G? For us, 5G for remote areas is a very important scenario, and we don't have in the 3 original scenarios ever some requirement performance adapted to the 5G for remote areas. We have a lot of motivations and applications related to this scenario, both in social and economic terms. We can highlight some applications in education, in entertainment, in communication, and digital integration for remote areas. It's a very important social aspects. We have about 4 billion people unconnected in the world now. It's a digital divide that we cannot accept anymore. And you need to provide the last frontier for universal access. In terms of health, we can also have some applications like specialized treatment, monitoring on the go and in home concepts. And we have also applications in roadways related to entertainment application, V2X connectivity, and safety applications. I would like also to highlight that the 5G can offer a huge opportunity to solve the digital divide problem that affect not only the developing countries, but also developed countries. It's important to remember that the increase in broadband internet access significantly influences the GDP of a country, and also to separate people from information and communication technologies and services is no longer acceptable in contemporary society. Particularly to Brazil, we have another very strong motivations related to agribusiness. We can provide innovation in agribusiness implementing smart farms and offering a lot of several new services like field automation, machinery platooning, cattle monitoring, drones for images and fertilizations. Also, this scenario can offer a new market for operators. We call this micro operators to provide the services in the rural areas. Here we have some numbers to illustrate the importance of agribusiness in Brazil. Agribusiness represents 23% of the GNP in Brazil and 48% of the exportations in our country. Another question is the gap of connectivity that you have here in Brazil. Brazil, as you know, is a huge country in terms of dimensions. To illustrate this, we have one municipality in Brazil, the municipality of Altamira, that is just one municipality is bigger than a country or several countries in Europe, for example. It's a huge challenge to provide connectivity in this kind of municipality in our country. What we are working here about the 5G for remote area scenario. We are working at Inatel on a project to propose solution for 5G for remote areas. This project called the 5G range remote area access network for the 5G network. Is developed in collaboration among several institutions in Brazil and also several institutions in Europe, like Universidade Carlos III de Madrid, Universidade de Dresden, University of Oulu, and Telefónica in Spain. In Brazil, you have Inatel, UFC, USP, UNB, Ericsson, and CPQD. This project is technically led by Inatel. What are the goals of the 5G range project? Is to provide mobile broadband in remote areas, overcome the current range limitations in 4G and 5G standards, to reduce the operational cost by exploiting TV white space in remote areas, to increase the data rate at the cell edge, and bring 5G services to rural and remote areas. The performance requirements of 5G range projects is to achieve a cell radius equal to 50 kilometers, offering a data rate about 100 megabits per second on the edge of the cell, with a mobility about 120 kilometers per hour, offering mobile broadband and Internet of Things services in this scenario. We have implemented here a prototype based on hardware. In this prototype, our solution is running in FPGA technology. And we have here some technical details about this implementation. And also we have implemented a software-based prototype. The advantage of the software-based prototype is a faster development cycle. Most block is implemented in C, and some functions are implemented using FPGA acceleration for high complex blocks. We have done a lot of field tests in Minas Gerais region, and now we are offering 102 megabits per second in a 50.6 kilometers far from the base station. That the performance requirements of the project have been achieved now. This summarizes my presentation, and we have I think this solution that we have developed here can contribute to the standardization for 5G for remote areas in the near future. Thank you very much, Jean-Pierre. Thank you all.
Thank you very much, Brito. That's quite nice. And here also you have absolutely wonderfully respected the timing of presentation. This is fine. So as I told for Kiran, Kuchi, I think we can ask questions during the panel, including on your presentation. Thanks a lot. Now let's give the floor to Professor Federico Boccardi, Principal Technology Advisor at Ofcom. the UK regulator. Professor Federico, I had the pleasure to see your presentation last year at the Dresden September IEEE 5G World Forum, and I had not forgotten what you presented, and as you supported this 5G for remote areas, and also giving also examples not only in Brazil but also in UK, with mainly Northern UK examples. So please, the floor is yours.
Thank you, Jean-Pierre, and good evening, or good morning, or good afternoon to everyone, depending on where you are in the world. I think you can see my slides. So I wanted to bring the UK perspective. And I wanted to start by giving you the picture of where we are in terms of connectivity in rural areas. And this is not the most updated picture, because this is coming from a report we publish every year in December. So the next one is going to be due December in a couple of months' time, December 2020. So this picture is from last year. And in particular, I wanted to emphasize a couple of things related to 4G before going to 5G. First, there is a big difference in terms of coverage when you speak about coverage to premises and geographic coverage. When it's about coverage outside premises, in the proximity of premises, while there is still a big difference between urban and rural areas for the 4 operators in the United Kingdom, even in the rural areas, we are beyond 90%. So more than 90% of the premises are able to be served by at least one operator. Now, the picture is very different if we go to geographic coverage, and in particular, if we consider the different nations that are part of the UK, Wales, Scotland, Northern Ireland, and England. In particular, Scotland and Wales, which are rural areas, you can see that geographic coverage is it's still not as good as premise coverage, is well below premise coverage. In particular, for example, if we consider Scotland, for a couple of the operators, we are below 60% of geographic coverage. 5G, where we are with 5G, 1 year ago when we published this report, 5G had been deployed by all the operators, or let me rephrase it, all the operators in the UK have started to deploy 5G. We counted at least 40 to 50 cities and towns where 5G was deployed. This year, we think is much more, and one of the operators said, for example, that they have 5G in more than 80 cities or towns. So, looking at these numbers, what we can do to improve these numbers. So, one main action the government took during the last year is the Share Rural Network. So basically, this is an agreement between the UK government and the 4 mobile network operators. The UK government is committing £500 million, and there is a similar amount matched by the UK operators to deploy a Share Rural Network shared by the 4 MNOs, which is made in part by existing sites and in part by new sites, and the objective of this Share Rural Network is to increase the areas where there is at least one operator from 91% to 95%, having geographic coverage by all the operators from 66% to 84%, and having each operator with at least 90% of geographic coverage in the UK by 2026. So this is quite massive. This is quite a massive improvement with respect to the past. Now this is 4G, and I think your question could be, what about 5G? we're going to come back to the panel later, but what I wanted to say now is that our vision is at the moment, in the short to medium term, in rural areas, in areas where there are no capacity problems, when the number density of users is not very high, 4G should be able to satisfy the majority of consumer needs for apps and services. Whatever, there could be businesses that need more, and for those cases, we are considering different policy measures. One of these measures is related to spectrum, and we have been releasing, and we are releasing different spectrum bands, ranging from very low spectrum to very high spectrum. So probably you could say that this very high spectrum is not particularly relevant for rural areas. However, and in particular, I'm referring to the 1.8, 2.3, and 3.8 to 4.2 gigahertz spectrum. In UK, we have recently released this spectrum for local access. So it is shared spectrum that can be accessed locally. And why is it relevant? Because if there is a business that needs to have a higher data rate or quality of services than what achievable via existing or future rural networks, then they can use private network, for example. And this is an example of a type of applications you could have with shared spectrum bands, for example, via private networks. And as I said, we have released different types of spectrum bands. Some of them is only work indoor, some others work outdoor as well. Some are for mobile services, some others are for fixed wireless access services. Some only address in-building use cases, some others are addressing rural use cases. This is about shared access license, but is not the only spectrum enabler that we can offer. Another one is a so-called local license, which means that wherever there are MNOs that are not using a given spectrum band that has been licensed to them on a national basis, then as Ofcom, as the regulator, we can facilitate access to this spectrum by other players. And one example is some local operators targeting very rural use cases. So, for example, providing coverage in camping sites, in touristic areas where today there is no coverage. They could use MNOs, network operator spectrum, locally in those places. And as Ofcom, as the regulator, we can help to facilitate. And again, on private networks and on local spectrum access, part of what we've been doing is trying to understand the needs of different businesses in the UK. And yes, a lot of this is about industrial businesses and industrial use cases. And the one at the top is a supermarket chain in the UK, and that's how they use wireless basically to drive remote robots that are automatically picking up items in a factory. That's one use. But a lot of this is about rural connectivity. So, for example, there is a project called 5G Rural First, which is a research project financed by the UK government, which is looking at using private licenses for salmon farming. So these are salmon farms. Is a very important business for Scotland, and it is in very remote areas. Another very different use cases is to enable farmers in Wales to run innovative services. And these two are very different use cases because the type of skills that the salmon farm industry has got are very different from the skills that farmers in Wales have. So in thinking enablers, policy enablers, and technical enablers, we need to think about all the different needs in different parts of the UK. Finally, I wanted to say that in addition to this, we also it's also very important for us to provide information to consumers, and one way to do it is by providing coverage checkers, by keeping an updated maps on the availability of different mobile and fixed services in the UK. In the last 30 seconds to a minute, I wanted to close by saying this is only part of the story. In thinking about 5G and how to enable 5G services for everyone in the UK, there are a lot of different things that we are doing. What I cover in this presentation is mainly about improving connectivity in hard-to-reach places and lower the barriers for innovation. But there is a lot, and what Professor Brito, for example, discussed in looking at the impact of emerging technologies, either in the short term or medium to long term, is also very important. It's part of what we do as Horizon Scanning, and there is a set of activities we are doing within the UK and with international players in thinking about how to shape new technologies and how collaborate with players outside the UK. So I'm really looking forward to further collaborations with India as well. Thank you.
Thank you very much, Federico, for this nice presentation. Also, for the third time, also on time. So thanks a lot. We have now, and thank you for this Ofcom and UK, but Ofcom vision and perspective. Opening in your last slide on future networks. We will now go to the state transition to the panel, and we'll present briefly each panelist. So if we can go to transition to the panel, please.
Yes, sir, I'm doing that now.